Hi everybody, and welcome in the ultimate Kubernetes challenge. I think it will be the only one talk that will ask you to take your phone. Let's begin. So, I'm Aurélie Vache. I'm a developer advocate at OVH Cloud, specialized in cloud-native, Kubernetes, infrastructure as code, and developer experience. So it will be a mix of a quiz with illustrated slide and with demo. So the goal is to learn, to play, and have some fun. I hope so. So let's check the QR code. Normally, if it's okay, you'll see a blank page with a blue top. At the top. yeah. So it's okay. And if you if you answer correctly, you can win some swag and my book. Okay. I have created several Kubernetes clusters managed by OVH Cloud, one with 3 nodes, one with 0 node, and one with 3 AZ and 3 nodes per AZ. Okay? So, in this question 1, you should fill your alias. Is it okay? Yeah. Yeah, it's working. So, I will wait a little bit in order to wait, everyone is here. Okay. Cool. Another one. Let's see if it's okay for everybody. Yes, okay. Thank you, Abdel. So let's start. Question number 1. I have a Kubernetes cluster running version 135. Which version of kubectl should I install and use? 135 only, 135 or less, 134, 135, and 136, or it doesn't matter. It's up to you. YOLO. What do you think about this easy question? Yeah, easy. You're right. It's 134, 135, and 136. Congratulations to SDA. Oh, Abdel. It will change, yeah. So, kubectl supports one minor version of Kubernetes API server, older and newer. So, if the API server is equal to 135, you can install and use a kubectl version equal to 134, 135, and 136. Okay? It was an easy question. Question number 2. Ready? Yes, they are. Who is responsible for finding the best node for new pods? Is it API server, node controller, the scheduler, or kubelet? What do you think about this question number 2? Is it easy or not? Yeah, it's the scheduler. You're right. It's not the kubelet, no. Is it moving? Not for the moment. Okay. So when we ask Kubernetes to create a new pod, the API server calls the scheduler that will do its best to find a suitable node. When it found one, the pod is scheduled on a node. Question number 3. Yes, yeah, ready. In a secret, what is the name of the field that contains the secret content? Is it data, value, key, or secret? What is this field? Interesting. And the good answer is data. Yeah. It's not value, it's not key, and not secret. I will see it. Yes. you are fast. Yeah, it's good. So, several types of secret exist. Generic, Docker registry, and TLS. But no matter the type of the secret, the content is always in the data field. And we'll see it in a demo. So, let's switch in our first Kubernetes cluster. So, we will create several secrets. One with the generic secret from a literal password. Another secret, it's a Docker registry secret with the URL, the login, and the password of your registry. Okay. And the third one, it's a TLS secret with the key and your certificate. These three secrets are created in our cluster. It's okay. They are here. And we will see inside the first secret. So, as you can see, the password is in the data field. Okay. And for the registry secret, it's the same thing. The Docker config JSON is inside also the data field. And same thing for our TLS secret. The key and the certificate are inside the data field. Okay, it's cool. But is it really easy to get the content of this secret? In fact, we need to type a kubectl get secret with the name secret, the namespace, and we have to use JQ or the JSON path, and we have to know which key, and we have to decode in base 64. And trust me when you have to type this kind of command every day. It's not really. So the good news is that a kubectl plugin exists. It's view secrets, and it's it's a really useful plugin. You just have to type kubectl view secret with the name of secret, and that's it. You have your decoded secrets. Is good? Yeah. Useful. Take your phone. Question number 4. Ready? Can we create a namespace if we have 0 worker node? Is it true or is it false? Easy. Can we create a namespace with 0 node? Is it okay or not possible? Yeah. You're right. It's true. It's moving again. Yeah. So a namespace that allows you to isolate an application. It's a logical object. It is stored in etcd database, but it's not deployed on a node, and it is not a physical resource. So no pod and no node are required to create a new namespace. And we will show some things. So let's switch in our Kubernetes cluster with 0 node. Let's check it. So we have 0 node in our cluster. And let's try to create one namespace. So it's okay. Let's check it. My namespace has been correctly created. It's okay. But if I want to delete a namespace, what will happen? So I can wait 30 minutes, 1 hour, 2 hours, and the namespace will be never deleted. Yeah, never. Why? Let's show it. So, indeed, the namespace controller tries to list the API, but it can't. Why? Because the metrics server is not up and running. So the namespace controller can't delete the namespace. So you can create one, but not delete one. Kubernetes. Yeah. Indeed, yeah. Let's start with a question about 5. Get ready. Yeah. An HPA is configured for a deployment with a CPU limit, but no CPU request. What happens? HPA cannot be created without CPU request, or the HPA works normally, or it never scales, or it scales infinity. Ah, I like it. I like it. So you think that in between the HPA works normally or it never scales. So we win. The HPA will work normally even if we not defined CPU request. And I will see it. Oh, Abdel is on fire. Tony too. And Nikolai also. So, thanks to a horizontal pod autoscaler, we can autoscale the deployment when a CPU or memory usage exceeds a percentage. Concretely, the HPA controller reads metrics CPU or memory from a metric server. Then it compares to the HPA UART, and then it adjusts the number of replicas. So if you define a deployment without any CPU request and without any CPU limits, the HPA will fail because it can't calculate the CPU consumption. So the number of replicas will never increase. But, there is a but, if you define a deployment with only CPU limits, the HPA will work because of the not so well-known API server superpower. And we'll see it in the demo, of course. So let's switch in our cluster. So we will deploy an application with only resources limits. So our application, it's a deployment named my-app. And as you can see, I define only the CPU limit. And we will also deploy the service in order to reach it, to access to it. So I apply my YAML file in my cluster. Let's check if the pods are here. Yeah, my application is running. Okay. Let's check the resources of the pod. We can see it with the kubectl get pod command, and thanks to the gq command, we can display only the name of the pod and the resources. And as you can see, even if I define only the CPU limits, the pod have the request and the limit. So, yes. So they have been automatically injected by the API server. So now, let's deploy a HPA. So we define a HPA, name my app HPA. It will adjust the number of pods to have an average CPU consumption equals to 40%. You can find the number here. So let's apply it in the cluster. OK. Let's check if the HPA is here or not. Yes, it is here. And for the moment, it does not have the time to calculate the CPU consumption. OK, so let's simulate an activity to our application. So we will execute wget command to our application in order to simulate an activity. So every time my application have a request, I display OK. And as it's an application in Go, the CPU usage is low, so we have to wait a little bit in order to simulate the activity. Let's wait a little more, but it should be OK. It should be OK. Allez, let's go and test if I wait less or more. So we have our HPA, and let's wait until the HPA check the new CPU consumption of our application. So we have to wait a little bit. It will check from the metric server. 71%. Yeah. So the number of pods will increase normally. Drum roll. So yes. So the HPA works. It's cool, no? Yeah, it's cool. Let's check the number of pods of our application. We have now 2 pods, so the HPA will work even if we don't define the CPU request, thanks to the HPA server. OK? OK. Question number 6. Ready? Yeah. A Kubernetes service can distribute traffic to any pod that match its selector, 2 pods running in same zone as the client, 2 pods running on the same node as the client, or only 2 pods created by same deployment. You have to check several good answers. OK, so you think it's the first one, and maybe the second one, no? In fact, is the third one. A Kubernetes service can distribute traffic to any pod, a service, 2 pods running in the same availability zone, and also 2 pods running on the same node. The leaderboard has a little change. OK. So when we create a service, behind the scene, an endpoint size object has been created. It refers to a set of endpoints with some function like the pod's IP, name, the namespace, but also the node and the zone. And thanks to that information, we can do traffic routing to a specific node or a specific zone. To do that, we have to define the traffic distribution field in our service. A little information, traffic distribution field allows to express preferences. If you use Cilium, First, you have to check that the topology aware routing feature is activated. And for your information, the prefer same zone and prefer same node value are not implemented for now. The good news is that I created the issue months ago, and in the next release, this value will be implemented. So, yoo-hoo! It will be good. Let's demo it. So, let's switch in our cluster with 3 availability zone. So let's check what is the node. So I have 3 node pool with 3 node per node pool, 1 in zone A, 1 in zone B, and 1 in zone C. And we have 3 nodes, 3 in zone A, 3 in zone B, and 3 in zone C. Okay? Let's try to route traffic to pods running in the same AZ. So let's see our deployment. We have a deployment named rediscover with 3 replicas. Okay, it's a simple Go app, and we will define a service with the traffic distribution field equals to prefer code. In my cluster, I have Cilium, so I have no choice for now to use the alias of prefer same zone. Let's apply our deployment in the cluster, okay? And let's apply our service in order to access it, to our application. Okay, so as you can see, this service has been created in the cluster. And behind the scene, even if we never created an endpoint size, as you can see, the object is in the cluster. So we have the list of node, zone, and all the information to route correctly the traffic. The node is here, the zone is here, etc. Okay, so let's have a look to our pod. So we have 3 pods, 1 in our zone A, 1 in zone B, and 1 in zone C. Let's create a new pod, and every time we will execute the curl command to our service, we will see where the traffic will be routed. So, okay, all the traffic have been routed to my zone C. So let's check where are our pods. Drum roll. So the sender pod is in my zone C. So we do traffic routing to my zone C. It's okay. So it's working. Yeah, it's working. And the last question. Take your phone and be quick and be accurate. Yeah. Go. Okay. Question number 7. Last question. 3, 2, 1. In a cluster with 3 nodes, if a pod is configured with an affinity required during scheduling that cannot be satisfied, what happens? The pod is scheduled or not, the pod is in pending state, the pod is in crash loop back-off state, or the pod is deleted. It's quick, yeah. So you think the pod is in planning state? Yeah? You're right. So who win? Oh, congratulations, Abdel. So congratulations, Abdel, Esda, Ibak, and so on. Go at the end of the talk, and I am so I have some swag for those people. Congratulations. So. With Node Affinity, we can configure two kinds of rules. One soft rule and one hard rule. So with prefer during scheduling rule, the scheduler try to find the suitable node, but if it's not possible, it schedules the pod whatever the node. YOLO. I don't care. But with retry during scheduling rule, there is no work around. So if zero node satisfies the condition, the scheduler can't find a node. So it tries, it fails, it tries, it fails again and again, and the pod stays in pending state. Let's see it in the last live demo. So let's switch in our cluster with 3 nodes. Let's check what are the labels of our node in the cluster. So let's see, yeah. So we have a node pool equals to my np label in my nodes. And we will try to apply to deploy a pod that have the required doing schedule rule and that have a value equals to KCD Helsinki. So the pod will only be scheduled a node with this label. So let's try to apply the pod on the cluster. Let's check if the pod is running, and no. We can wait 1 hour, 2 hours, and the pod will stay in the pending state. Why? Let's see it. Because we have 0 node with this key and value label. So the pod will never be scheduled. I hope that this not common talk with a mix of quiz, some slide, and some demo was good, and I hope that you have learned something. Since a lot of years, 5, 7 years, I wrote some posts and some books in a visual way. So, so I try to make complex things accessible to anyone. Kiitos.